Thanks, Brian. Thanks, Brian, for this opportunity, and thanks for that great intro. So, hello, everyone. So, Brian gave me some of background that what I do now. So, currently, I work as I can say I worked as a data engineering lead for a company named Kafu in Dubai. And previously, Brian and me we used to work together for a company called Property Finder. So Brian was in geospatial space, and I was in data engineering, and we worked on a couple of projects together, setting up the geo infrastructure, and anything that's related with data. This kind of interaction we used to have, and that's where we developed uh, our relation on the professional space, and we used to do a lot of brainstorming together while working there. Prior to that, I was in United States. I did my master's in computer science, and after that, I did a couple of internships. Like I heard couple of many of people who are present here, they are doing their masters and also parallel doing internships in geospatial area. So I did internship at Qualcomm uh, as a in the data analytics team. Performed a lot of network data analytics. It was all called related to we what we internet that we use today, like related with 3G, 4G, 5G. Now 5G is rolling out, but I was working on that type of data like back in 2017. So it means that back in 2017, the work on 5G was going on, and slowly and steadily now it's getting rolled out. Uh, and after that internship, I also got a full-time opportunity in the same company, and I got to grow my data skills, which actually landed me a senior data engineering job in Dubai, and I transitioned now to a data engineering lead position. So today I will be specifically talking things and walk you through that what data engineering space looks like, how you should transition your career, or what tools and technologies you should be working on, what are the core skills required, what's happening in the industry, how do we consume data, where do we like normally store it, how the processing happens, how the ETLs and ELT things are being set up, and then how the things are being presented so that the management people, the key stakeholders, who are usually the C level guys in your company, they are only interested in the visualizations and insights, so that they can take key business decisions. And that's how the data industry is moving today. And yeah, we will touch base on some of those aspects, and I hope it will help you too, and you will enjoy the session along. And after that, at the end, we will open up for questions, and anything you want to know more or in depth, we can discuss during that Q&A session. So, how will I structure this? Is uh, I'll start from like what I mean. I don't have any kind of PowerPoint slides, I, because I want to give you the real world perspective. I don't want to show you some bunch of any text and things. Sometimes it also gets kind of boring. So I will be realistic, and what's actually happening in the industry. That's all I will speak about. So right now, as being a working as data engineer at Kafu, so I'll present it in terms of story. So when I was hired, I was being given a very big task. The company itself, they didn't have any kind of data platform. So the data platform itself was missing. And I was the first guy in the company to be hired in a data engineering. And how the analytics used to look like is we had Power BI. So Power BI is a visualization tool If some of you have not heard, it's like Tableau, QuickSight, and there are so many others. Uh, and it's used for building dashboards. So how the analytics was performed is we have a couple of analytics guys in BI team, and the Power BI was directly connecting to the read replicas. So in short terms, they were directly connecting to the production sources. Uh, and what was the downside of such setup is you can't do any kind of complex analysis. Since it's the start phase of the company is just 2.5 years old. So for certain time it went well. It was okay. Uh, Writing some queries within the BI itself, and the query runs against the actual sources, and you get return. The data is returned. You do visualization. It's fine. But soon as the data grows, you'll start facing problems. And also, if your once your data sources grow, so your data sources not only lies in an RDBMS, so they come from event systems, different kind of event systems. There is also IoT. So event system, when I say event systems, like for example, Clever Tap. So the Clever Tap is responsible, like it's integrated with your, can integrate with your mobile application, and whatever events are going on within the application. For example, you are viewing something, you click something, so all such data can be recorded to do some kind of user behavior analysis, that how you are using the application. And from that, we come to know that what should be changed in the application itself, how we should improvise in certain area. All this analytics is being done from that data. So as the number of data sources becomes increases, so then such kind of setup will not at all work, and you will be limited on the set of things that you can perform. So that's where the challenge came in, to have a such kind of architecture where things can scale, and you can store in more data, process more data, and then uh, have the capability. I mean, give the power to data scientists, analytics team to do data explorations, join across varied sources, let it be structured, unstructured, semi-structured, and they can perform. I mean, well, the performance should be good, and and then they can work on variety of use cases they have in their mind. So with that kind of discussions, so what architecture I came up with was, which is now very quite popular and has become quite popular in the data industry, or in the software world, is setting up a data lake. So the term data lake, what does it mean? Since many of you guys, you're already working in geospatial area and you work with data, you might know that the companies, or within your curriculum too, since most of you are also in masters, if you have taken any database courses, you might have come across these terms: data lake, data warehousing, and also now there is a new term that's been coined, data lake house. We'll come to that. But for those of you who don't know, so data lake is a central repository. So what does it mean is you have 10 sources in your company from which the data is being generated. You get the data from all these 10 sources, and you store in a central repository in its raw format. So you don't do any kind of processing over it. So you store the data as it is. So as it is, which lies in their actual sources, you get the data from there, and you store the data in a central repository. So that is what called, being termed as a data lake. And you have, it's kind of a, so to simplify it, you can imagine a library. So when you go to a library, you have a librarian, and you have information like the books related to so many particular areas related to politics, technology, uh, in arts, history. So there are so many other streams. So this can be considered as different kind of sources of data, sources of information, and you can relate it to these data sources in a company. And all this is being stored at one central location, and that central location is the library. And to manage it, to administer it, to take care of the library, to take care of the books, to order new books. So you can imagine ordering new books means getting new data sources, getting new data sets. So it has to be, you need someone to perform these activities. So that activity is being performed in a library by a librarian, and that librarian, you can relate it to a data engineer. So what a data engineer does is responsible for making sure that the data, wherever it lies, it's secured. Then as and when the data sources increases, you get that, bring the data, have the processes developed to get the data from the source, store it in a central location, administer the data, have the access, big controls being set up over the data, and all the necessary things. I mean, it will be encryption, whatever, like around information security. So he is the guy, data engineer, who does all this work. And usually they are being also called as plumbers of data science, because they deal with, like, what I call it as a data shit. Because plumbers are responsible for working the hardcore work. That's what the data engineer does in a data team. And the data can become like become very messy, and all these things has to be handled by a data engineer. And with that, you need to develop your quite can become quite complex, and you need to have that level of skills, so that you solve those issues. So once the data lies in a like a data lake, so that's when all the processing usually happens in today's industry. So now what you did is you shifted your processing right from the sources to the data lake. The advantage of this is that you have data from all the sources at a central location. So that one task that becomes easy is to view the data across sources and to join it across different sources. That becomes very much simpler, and it's kind of a power that BI people and data scientists usually, in any firm and in our company, they needed that kind of thing. And due to that, uh, they were able to do a lot of complex analysis. Let it be because we are in fuel delivery space, so we had a problem around routing engine. We had to optimize the routing engine because we had trucks going around in the field, and we have to deliver orders. So predicting any kind of ETA, also deciding the route for the truck, all these things can be optimized only you have, if you have enough data. So now, after collecting data from so many other event systems or third-party systems, wherein like CarTrack, Fleet.io, wherein all the truck information is stored, then also the IoT, we have IoT data. We have a lot of sensors on board truck. Let it be fuel level sensor, fuel dispenser, and a lot of other parameters related to the truck. So all this is being, it comes through the data pipelines and it lands into data lake. So the data scientists and data analysts, they are able to do data munging, crunching. They are able to write SQLs and come up with the solution for the use case they are working on. So that's how we were looking at the data. We were able to optimize a routing engine, and also the thing related to the ETA to give the like accurate, almost accurate ETA to the customers who are ordering the fuel. So that's the power of data. And so to have that kind of power, have you have to organize the data well, and that's why the source of data nowadays is considered single source, is to be the data lake from which all the analytics is driven. So now what happens is once data is lies in the data lake, the BI team or your data scientists, they are responsible for doing data explorations, uh, drive some kind of initial insights from the data which is there. And depending on the business use case they have, now data engineer will work with those guys for creating daily ETLs. So the ETLs can range from, it can be a daily ETL, some ETLs are also real time, some are hourly based. So depending on the different use case, you can have different designs or design patterns for ETLs. And all these ETLs, you have to schedule it. And now and what happens is ETL usually it's cleaning and transforming. So the data in the data lake is raw, and you can also there can be some kind of noise in the data, which is available in the data lake. It's not perfect, so that's why we need to have ETL processes, so to clean it. For one kind of example is timestamps. So maybe a data coming from a MySQL source, the timestamps were stored in UTC, but the other source, like for example Postgres source, I'm getting a data from other Postgres source, and there the timestamps were stored in maybe other kind of, maybe local time zone, maybe they were stored in Dubai time, or maybe in American time, or any other time zone. So to have a unified interface so that you have a standardized logic for these timestamps, you have to make sure that you convert it to a standard format, and also the format, whether you are following year, month, day, or month, day, year. And there are so many other date formats. So to have that kind of timestamp standardization, all these things that can be decided into the ETL, and which, like for example, which zone you have to stick to, and what kind of format you want. So all these things, this logic goes into ETL, and that's where you decide on the missing values, if you have any, what to fill it with. So that is the part of the cleaning and transforming of data. So once that process is done, now the data has to go into a target, and that target usually is a data warehouse. And when I say data warehouse, means there is some kind of a management system. Usually nowadays, as industry works on cloud, so you have a lot of cloud-based data warehouses. So one of the such data warehouses is Redshift. So it's by AWS, and it's managed by AWS, and you can directly use their data warehousing service. If your company is working in AWS, if you have application set up on AWS, then you not do much things. It just a matter of a few clicks wherein you instantiate a cluster and start using it. So we use Redshift because it's a managed solution, plus it can handle petabyte scale of data. Even if the data grows to petabyte scale, Redshift is designed in such a way that you can easily scale and handle the load. And plus, there's maintenance is there. Any kind of database involves you. There is some maintenance you have to do, but majority of it is handled by AWS, and you need to take care of some of the things here and there. Like for example, a clustering mechanism, we are partitioning data, partitioning schemes, that how to distribute your data across the node. So such kind of activities, metadata management activities you have to perform. Uh, and now once this cleaned transform data set goes into Redshift, now what you can have is the next part comes to present this. Now you have your data sets into a target, the use case you're working on. Now you have to build visualizations like dashboards. You need to present those results to your management, your key stakeholders. Now that's wherein now what we did, we connected our Power BI to Redshift. So earlier the Power BI directly used to connect to the actual sources, but now that source is cut off, and now the single source of truth for Power BI is the Redshift data warehouse. So all our business use cases, the ETLs related to it, and all the clean transformed data sets, they lie into that data warehouse, and we have all our dashboarding built out of the data, which is in Redshift. And once the dashboard is being built, the Power BI in itself has different mechanisms that when to refresh and how to refresh and what time interval it should refresh. So you have up-to-date data being presented, up-to-date visualization graphs being presented on Power BI. So all this overall journey, right? You saw like there is actual source of data, wherein like application data is stored. In our case, it's an application, computer application. It's a mobile application, and the backend for it is there. Are depending on use case, there are many backends. One source is MySQL. Some of the data is goes in Postgres. Some of the data comes from event systems. I talk about like Clever Tab, this semi-structured data. Some of the data comes from IoT, that's also semi-structured in, so the actual is in JSON format. So that's that source. The second is bringing the data, like doing an so it's not at ETL, so doing an EL job. It's called as extract and load. So we extract from the source system and we load it into a data lake. So we have to run EL jobs to get the data into a data lake. And then once the data is in data lake, then you can write your ETLs, which is extracting from data lake, transforming, and then loading it into a data warehouse, which is the actual target. And after that, you have the visualization layer. So as part of this, like for setting up, like you might have this question that how should I construct this data lake? What components should I use for storage, and where should I do it? Now that also depends on your company decisions. For example, now we purely operate on AWS space. So we use AWS components use AWS components for architecting the entire data platform. But you might work on Azure, you might work on Google Cloud, and they have the similar components that's available. So they have their own data storage systems, big data processing systems. So the architecture wise, it doesn't change much. You just have to make use of related components what's available in the other clouds. Or there is also like your company might work on premise. You don't work on cloud because of things related to data security, and your company works on premise. And you can also set up things on premise, and so you have open source tools like Hadoop, HDFS. For example, HDFS file system can act as your data lake, as a central data store if you're working on premise. If you're working on AWS, in our case, so you can have your data lake as S3. So S3 is an object store. It's a simple storage service, and it's quite cheaper to store information in S3. And it's all the things are being considered as objects. So there is a difference between a actual file system and the object-based file systems. So they are basically called as object stores. So the difference lies in how the information is stored in such stores, and how do we retrieve it. But that's very abstracted. As a user, you won't come to know. You will think that okay, this is looks like a normal file system, but under the hood, the architecture and the technology is a bit different between uh, for like for example, other than there is Linux file system, there is network NT file system, then you have HDFS, there is S3, there is Azure Blob. So all this, there's subtle difference between all these kind of architectures. But your S3, if you're working on AWS, can act as your data lake, and you have all your the data from all the sources stored there. And the next question becomes like what kind of format should I use basically for storing the data. That's also a very key decision, and that's actually the decider if your data lake environment will succeed or it will fail. Because if you are storing terabytes of data, then you can't just store them as CSVs. The reason being, the core reason being is the CSVs they follow row-based architecture. I mean, when you try to query over CSVs, it's row-based. If you know the difference between row-based and column-based. It will scan if you write the select XYZ from XYZ column from XYZ table. Then even if you mention one column, it will scan the entire data, which is not very efficient if you have terabytes of data. So that's why I need to choose on what kind of file storage format you will use. So for querying over big data, usually what we prefer is storing the data in Parquet format. So the Parquet is a columnar file format. There's also some other similar formats like ORC. It's also column-based format, and there are two big reasons why such formats are used, because it provides huge performance improvements over S3s and JSONs, and second is the compression. They offer great compression rate. So against like if 100 maybe a 1 GB file of CSV will be mm, around, maybe I don't know, maybe I think 100 or 200. It will consume 100 or 2 MB. It will be compressed to 100 MB or 150 MB if you store it in Parquet. So that's the kind of compression rate. It will offer you 6x 7x compression. And basic, and there is a compression scheme also. Usually the default scheme is snappy. It's called a snappy compression when you are storing for your data in Parquet file format. So once your data is in Parquet format, the now how it offers performance improvement is if you write a query, like there is an employee table, suppose hypothetically, and you need ID and name of employees, and you write a query called as select ID, comma name from employee table. Now, since it's a columnar file format, it will only scan the data for ID and name column. So even if there are 10 other columns, it will filter out those data. It will neglect. It will only project the query on your ID and column, ID and name column. So that's how the data scanning is reduced and the data is being retrieved faster. But if the same data was in CSV, even if you have mentioned ID and name in your query, it will under the hood scan the entire data set. So that's why the in big data scenarios, you try to avoid in Parquet or ORC because of the compression and also the query performance it gives. So so there is also another layer, like what we once the data is in S3, you have stored it in Parquet format. Now what tool should I use to query it? So there are a lot of open source tools available. One of them is Presto. It's a distributed SQL query engine. So it's not a database, it's a query engine. So it works on concept called as query data where it lives. So your data lives in S3 files. So when you write a query in Presto, it will do the projections right where the data path, whatever you have mentioned for the table, and the query is projected over the data, and then the results are computed and it's presented to you. But usually what happens in other database systems is, for example, MySQL, when you write any type of queries, the data, all the data gets loaded into the RAM of that server, and basically all the data, and that's wherein it my MySQL database and other such database, they are not being used for doing big data analysis, because you just can't have unlimited RAM. There is always be some limitation. So you will have to use the systems which are more catered towards doing that kind of analysis. So Presto is one such system. Presto is called as Presto SQL. You can search over. It's called as Presto. Presto. Maybe I can also type it in the chat. Uh, and you can set up your own Presto cluster, and it can be uh, n nodes. I mean, whatever, depending on your data size, you can have a 5 node plus Presto cluster, 6 node Presto cluster. Or if you are also working on AWS, like how what I chose is because since we have resource crunch, so what I decided was to use AWS variant, and it is called as Athena. So Athena is AWS variant of Presto. Uh, it is purely managed by AWS, and so you don't need to worry about how it scales and what kind of resources I should allocate for the query, because there are a lot of query management related concepts. So since it's managed by AWS, all those things are taken care of by them, and the power of that is it will scale by itself in the background. You need not instantiate any kind of cluster on your own. For example, if you set up Presto cluster or by yourself, like in-house Presto cluster management, so then you have to define the scaling policies. But if you use a AWS managed product, all that kind of overhead is being shifted to the cloud itself. So that's wherein brings in the ease of use, and also a lot of maintenance activities reduced. And if your team is very small, then using managed services becomes more beneficial than using in-house related components or self-managed services. Athena is one of them. All the Presto queries, they work in Athena. And so once and Athena, it works with, now you also need to have a data catalog. So in AWS, we have a Glue, AWS Glue data catalog, wherein all the metadata information. So when I say metadata information, all the information related to tables. So like for example, I have an employee table. So what columns should I use from that employee particular file? So ID, name, department, salary. There's so many other can be columns. So you can define those columns, their data types, then where that particular file lies on S3. So you defined as part of that create statement, and this metadata information gets stored in AWS data catalog. And then Athena interacts with AWS data catalog, and using that information, it projects your query over your data on S3, and it will retrieve the results. So that's how, in terms of how it works under hood. It's a very high level thing I told you. But of course, if you have to read in depth, you can always go to the AWS page. They have more information. So I'll just write the data catalog service name. Called as AWS Glue Data Catalog. Uh, and So the AWS themselves, they provide a query editor, so you do not worry about it. So there's an Athena query editor you can use to query over your data, and all your team members, whoever is within your team, like be data scientists, analysts, or we also have a growth team here. So our employees, they go in, use that query editor for querying over data in our data lake. So for a user, like end user, uh, so for example, you are a data scientist and you are not that good in terms of software engineering principles, or you don't know how the big data environment works. You are being hired for doing mathematical modeling and statistical knowledge, but you don't have much information related how the data is organized or stored. Then for you, you will think that the Athena or Presto is kind of a DB. It gives you that resemblance, that feel that you're using some kind of a database, but it's not a database. The data lies in pure S3 files, and you actually, the beauty is the Athena or Presto system is designed in such a way that it projects the query over your data where it lies, where it lives. So it's quite a interesting concept, and I will recommend you guys. You can, if you are into data space and you want to make a career in this, you read about that those architectures, distributed architecture. And once you are in, let it be geospatial or data engineering, and now there is also a title called as geospatial data engineers. All of us, we need to know about distributed computing, and to go through such architectures is a great learning. So I'll recommend you guys, you go over the Presto DB architecture, and you will actually come to know what I am speaking. Maybe for some of you might go over the head and it might not relate, but maybe once you go through it and watch maybe some YouTube videos or read over it, it will make sense. Uh, and Now the next aspect becomes like how, like what tool should I use basically, or what language should I use to connect to the data sources, crunch it, bring it to data lake. So there is one very good tool, is open source tool, and it's called as Airflow. So Airflow is a workflow management tool. It's basically used for writing your data pipelines. So let it be EL pipelines, as we spoke about, extract from source and load into a data lake, those kind of pipelines, and plus the ETL pipelines, like extracting from data lake, doing transformations and loading into data warehouse. So for this, any of these design patterns, you can write your data pipelines and you can use Airflow. And Airflow is a open source software. It's developed by Airbnb, but now it's open source, and it's all Python based. So everything in that tool is tag based. It is directed acyclic graphs, and you define your graph, and all that you have to do is using Python. They have a lot of integrations, third party integrations, a lot of integrations with all major databases, file systems, AWS, Azure, GCP. The custom wrappers are available, and even if the wrapper, any kind of wrapper is not there, it gives the flexibility to the developer to write it. And good thing is everything is Python based, so you can make use of that particular tool. And there are also similar other tools that have come up. It's called as Daxter, Prefect. So it's Airflow. It's called as, it's under Apache now. It's called as Apache Airflow. It's for workflow management. So it's basically being used nowadays by big players for managing their data pipelines. And since it offers a visual interface, so there is an UI wherein you can go and you can see that which pipelines have succeeded, which pipelines have failed. Then you can, it also has a logging mechanism where you can see that why the pipeline failed. Then you can set up alerts. For example, we have set up alerts on Slack. Like for example, if my a pipeline of loading data from MySQL to data lake fails. So it will just trigger an alert and send me towards Slack that that this particular pipeline failed, and it will give me a path where I can go. And yes, yes, Steve. Nime is also a good tool, but mostly Nime is being used for machine learning activities. So it has a lot of inbuilt mechanisms for performing machine learning, and it's great for that purpose. Yep, but that's true. Nime is also good, but if you're purely doing machine learning and regression classification type of models, then yeah, Nime is great. But in terms of Airflow, it takes care of the entire cycle. So it's not only machine learning, since it's and you're not restricted. You can develop your own wrappers over it. You can define, write your own pipelines, and and have your end-to-end architecture, data pipeline architecture defined using a DAG. There's a directed acyclic graph, uh, and any kind of monitoring activities, logging, alerting. So it has integration with all these concepts, and it makes your life as a data engineer a lot easier. Uh, and later on, so this kind of tool can be used for EL and ETL purposes, for getting the data to data lake and from data lake to the Redshift. So this and so the idea now we spoke about was mostly around like batch data processing, like the tools like for example Airflow tool and these tools, they mostly cater to batch data processing. But if you have some kind of real-time use cases, then you have to shift your gears a bit, because real time is little bit different and more complex, and there is a lot of other particular components that gets involved. For example, you might use Kafka, where Kafka can be one of the component for building real-time pipelines. If you want to use AWS managed service, then it's AWS Kinesis. It's a variant, kind of a variant of Kafka, which AWS has developed, and they work on any kind of event-based systems, like how Kafka works, and and they have their mechanisms for data storage, and it works on the publisher subscriber model. And basically publisher is something, for example, if you have some data change happen in MySQL, so you can make it publish to a particular topic in AWS Kinesis, and you can have downstream players who will read from the AWS Kinesis for do perform processing and then store it into a target. And for processing those, you have a couple of technologies. For example, you can use Spark. In AWS, you have AWS Glue ETLs, and underneath they give you the capability to run Spark code. So that can be used for real-time pipelines. But the in any company that I have like observed, the number of real-time use cases, they are a little bit less. Most of it is batch processing, and mostly the analytics in major companies happens at T minus one. But compared to that kind of load, the load of for doing real-time processing is less, and is also like you have to decide that is it really the use case you are working on, is it really need to be built in real time, because you only want to build real time pipelines only if it's going to solve some purpose. For example, in our case, we want to know in real time that which of our orders are getting delayed. So this kind of information is very critical, and we don't want, when we want to know at that instant if the order is getting delayed. If we come to know like 4 hours down the line or 5 hours down the line, it's no use. So if we have such kind of use cases, then yes, you have to go around and we have to build the data pipeline. But if you have to do reporting, right, any kind of reporting that how many active users are there in my system, or how, or what was the number of order count until like over last 3 months, what's my order count, how it is it growing up, it is going up or it is going down. So such kind of analysis you don't have to do in real time. I mean, it won't solve any purpose. So this is mostly reporting things, and that can be done in batch processing, and that those kind of analysis can be t minus one. So you have, depending on the use cases, you have to weigh out that, and you have to weigh out like what is my end result and what I'm going to achieve. Like you will have to ask yourself these questions, that what kind of pipeline should I build? Is it real time going to solve my purpose, or even if I do batch processing, it's okay, because setting up batch processing involves less cost, and real time will involve very huge cost. Your cost like shoots up exponentially. So that's the reason why you have to dive in your use case, do some analysis, do some experiments, and then decide on any kind of production architecture. Uh, Now, in this particular like architectures, nowadays, what's thing is coming up is data validation. So once your this architecture is set up, but the next piece wherein the big data projects or any kind of data project fails is if you don't perform any kind of data validation. Like for example, when you develop an application, a software, you specifically have a software testing team, and that's there for a purpose, because whatever features you are going to provide, it needs to be of quality, and it needs to be trusted. And that's the reason why we have a software test. We in any company there is a software testing team, there is quality assurance team, so that the product that goes shipped out, it's of that grade. So same thing also applies to the data now. You just can't say that okay, I've written my data pipelines and data is flowing, but how to validate whether whatever you have done is right? So that's where now industry is moving. So right now we don't have a lot of tools for data validation, but it is coming up. uh, and now some of the tools, they are like not open source, also they are like third party, and you have to pay a lot of money. But now a lot of open source things are also coming up. I specifically started using library called as Great Expectations, and it's basically used for, for data testing. So how they brand it is doing performing your data testing and data validation. Once the data is stored in a data lake, or before going to to a data warehouse, you can have your validation script being run, and you can have it in the air, that particular task, that you can have it as a node in your graph, and that node can be called as data validation, and that you can perform using this library. And you can, like for example, what kind of validation, right? So you have some like any table, like let's take an example of employee table we are working on. In that employee table, we have a primary key called as ID, and we know that if it's a primary key, it can't be duplicate. So you can have one of the assertions or testing, like you can use this Great Expectations tool, and you can have particular test being set up on that column, that ID column should be unique. If you encounter a duplicate ID, just throw an alert, and don't load the data. And same thing can be done for name. For example, in name, it is like alphabets. Like there is no need of having any usually your, if it's a name, full name, it doesn't involve any numeric. So you can have that kind of checks that whether any kind of numeric thing is going into a name or no. uh, Plus now I like, for example, the id column itself, the id column should never be null. So you can have another that kind of check being set up on that column to see that are you with the data set, that new data set it's coming day by day, does it have any null values? if it if you encounter a null value, then just throw an alert, and you can throw an alert to a Slack channel. So this aspect of data validation, uh, then you can set up dashboards around it, like for monitoring it. For example, a whole monitoring piece, right? Yeah, this another important aspect. So we specifically use New Relic. AWS also specify gives us a lot of things around doing any kind of monitoring. And when I say monitoring, is you have such a huge cluster. Like for example, you have an if you have set up Airflow. For example, in my case, I've used AWS ECS, Elastic Container Service, to set up my Airflow cluster. There is a Redshift component. Then there is like S3. Then there is RDS for storing the data, and there are EC2 instances wherein the processing happens. But you have to make sure that all these things are up and running. Though AWS says that they will say that from their side it will be 99.99% of the time available and up, but you also need to, if but there has been cases wherein it has gone down. Recently, like a couple of 3 months back, there was an outage, and a major portion of the internet has had faced intermittent issues. So such things they happen. So you have to have monitoring for that purpose, so that when such disaster happens, you come to know immediately, so that you can take corrective actions. So for that purpose, there are a lot of tools. AWS provides by themselves some of the tools, uh, but they're not that friendly. So that's why we went ahead and used New Relic. It's used for specifically for your infrastructure monitoring. All of your infrastructure components are being registered with that New Relic tool, and uh, all your SLAs, it can be defined there. I'm sorry, not infra solution, for infra monitoring. And you can have it monitored there too. For example, it gives the capability to set up an alert if my EC2 instance capacity, like for example, I have utilized 90% of my hard disk space on EC2, then send me an alert. If the CPU utilization is greater than 80%, send me an alert. If my memory being used is more than 90%, send me an alert. So such kind of monitoring alerts you can set up. And then that and getting this piece of information, you make sure that your infra data platform is running as expected, and there are no outages, or the end users, they don't face any issues. So all these aspects, they somehow come into the data engineering aspect. The work of a data engineer, right, it's not only limited, as we saw, to writing any code, or just writing any ETLs or data pipelines. It's much more beyond that. The For example, we saw data validation piece, then this data monitoring, infrastructure monitoring piece. All these things also have to be done by data engineer. And more than that, we have not touched base on is information security. That's another aspect where you need to have some level of expertise, because as you know, as and when there are data breaches, they go on. And data breaches, they happen in big companies. Not even, like for example, even Amazon and Facebook has been breached a couple of times in the past. So you can imagine that how important it is to have the information security practices in place. And there are specific tools itself. And again, like if you're on cloud, the cloud environment has a lot of things you can have to specify, like basic things like access control, like what particular, for example, if you have a marketing department, so you can only expose marketing related data to those departments, and you can restrict them from viewing other data. So it drills down to the concept of building on the concept of like data marts, wherein it's specific to that business unit, and you restrict them not to view any other data which is outside their business unit. uh, and that also, this kind of principle, data engineer is responsible. So he's basically responsible for getting anything from getting the data, cleaning, transforming, making sure that the right data is in place, and if there are any anomalies, catching it, repairing it. There's a lot of activities that goes on, uh, other than any, like, there are like a lot of housekeeping activities, I will say. So the presentation, right, any kind of presentation layer. Now if you want to do any mathematical modeling or machine learning, so that only accounts like for 15 to 20% of the work, but the 80% of your work goes on setting up the infrastructure, monitoring the infrastructure, writing your ETL processes, monitoring your ETL processes, fixing them, that's, and cleaning, like for example data cleaning. That's the 80% of the job. And the 20% then is something you can develop a machine learning models and then visualizations, but that only accounts for the 20%. 80%, the whole big chunk, is actual engineering. And if that's not being set up properly, for example, if you don't have data validation thing in place, then some garbage will come in, and so it's like garbage in and garbage out. That means your visualizations you are performing or machine learning models, they won't perform properly, because you are not giving it quality data. If you don't provide quality data, that means your model can't perform the way you want, and the decisions you will take from that, it will not be accurate, and it will hurt your business. So that's the reason why all this data engineering specifically becomes very important. And that's how they, I just touched based on few of the topics. And and since we are running out of time, I'll just like stop for my session here, and I would like to like hear from you guys whether did you follow, or if you have any questions, we can pick up that.
Yeah, sure. Yeah, it has been actually great and clear. I hope to most. Is someone still not clear or
Yeah.
sure what a data engineering role entails and what it does? Because to do a summary here, just summarize. For example, you get data from various sources, right? Put it in a data lake. Then after that is like doing extraction and loading. You don't do any transformation or any stuff there, just as it is. And it's good to save data not in CSV format because CSV, when you query CSV, that's computer intensive, right?
Yeah.
It's good to have other data formats, right? And then after that, you can do the loading, HCL, extract, transform, and load to a data warehouse. And this is where now the dashboard and analytics can happen from that area. And in between, there's so many tools, so it's not about repetition, just to make it clear. A data engineer is about getting the data from the source, processing it, storing, processing, and making it in a usable format for data scientists or machine learning engineers. Or
Yeah.
yeah, so basically that's it. And yeah, it's usually people usually start doing going towards data science, but they forget that data engineering is so a key role, because right now again the demand is there. There's a huge shortage for it, I think so. I don't know. Then how's
Mhm.
the demand in Dubai so far right now?
Yes, so the demand it's keep on keeping on growing, and
Yeah,
now thing is the demand in data engineering space. Now the industry has started realizing that a data scientist cannot perform all the activities. You need to power the data scientists with data engineers, because all the data quality mechanisms and all the setup you have to perform, it cannot be performed by one guy. So to take out some of the responsibilities from those guys, so that they don't only are being confined to do mathematical modeling, and they work on the business use case, but the other activities like data processing and all those things, it's being started, like industry has started realizing that we need data engineers for it. So the demand for data engineers now, it's increasing and increasing.
yeah,
The
and it's
role
also
is,
good.
yeah.
Yeah, it's also good that for us we have also noticed it because initially we never used to see roles that have geospatial data engineer, but from last year they've been popping up now and then. So think it's a trend, and yeah, it's about early birds to join and just to pick it up.
Yeah.
So yeah, I don't know if anybody has got a question or anything wasn't clear, or if the skill sets needed wasn't clear.
I think they have written.
Seems you're so clear then.
Yeah.
Okay, yeah. So
Hello, Bondi.
oh
Hi, just
Yes. Yes. Yeah.
sorry, I think I sent a dump of questions because I was writing things while listening, and this has been
okay,
great
oh
fun.
yeah, there they
Yeah,
are.
so, yeah, cool. Most of
Yeah.
them have even been answered, but maybe just for
Uh-huh.
public context.
Yeah.
Yeah, maybe just go through them, pick whatever you want. Thank you.
Yeah. So, like, so something that was not answered, can you just point it out so that
Yeah,
we can
Jordan, it
clear
would
it?
be
Yeah.
good to point out than reading
Yeah.
all through. It was
Yeah.
detailed questions.
Yeah. So maybe you can, what is more important in those questions, you can point out to that so can answer
Okay.
it. Yeah.
Let me load my chat again. But for one, I know like the last question about like wondering, going through the first 3 quarters of the talk, wondering where I should think to plug in my machine learning pipelines. Should I
Mm-hmm.
load from data lake or like, stale data or cold data versus loading near real-time data? And you talked a
Yeah.
bit about that. Yeah,
Yeah.
so
Yeah.
like that to me is
Yeah. Yeah.
answered. Maybe. Yeah,
Yeah.
okay, cool. Um,
So for
um,
your, yeah. Yeah.
go on.
Okay. Yeah. I'll answer that first. So for your running your at what state, so I will repeat it maybe how I understood is you want to know that at what stage should you plug in your ML pipelines. So usually that stage is once you get your data lake in a central type of store, like for example data lake, therein now you can start your data science activity, because now you that phase of data acquisition is there, but now what kind of data you need from the data lake, then you need to decide on. For that you will have to do some data exploration, and you will have to load that particular data set, and in that data set, and the rest of the process you'll be working on it, like data cleaning and all these things you will have to perform, and all the features that are you don't need, you can drop them, and then you get it to your model, and you have some inferences, and then model training or testing phases, and then deployment. That's all there. But once the data, I will say a good start is once the data is in a data lake, at that point you can kick off your ML pipelines.
Cool. Maybe like there's the other questions, but if I was to pick one for the interest of time, maybe the
Mhm.
question of how do I scale down this very interesting architecture to a small company? I have just small data in my small team. How do I like get the benefit of these very advanced data
Yes, yes.
engineering stuff?
Yeah, sure. So is there, like, for example, is your company work on cloud? Like, are they open to get your setup on cloud, or is it in-house?
But I have to say my small company is imaginary.
Yeah.
It's not a real one. Yeah, but yeah.
Uh, so for that, I mean, so either ways, right? So if it's possible for you to work on cloud, that will be great. So once you are on cloud, I mean, it doesn't matter how you scale, whether you're small or big. For example, like setting up a data lake, right? So even
Mhm,
if your data is in GBs, it's fine. It will work well. Even if your data is in terabytes, you might have to tweak some things here and there regarding file formats, and some kind of query performance mechanisms are there. But it shouldn't matter. I mean, and for example, if you don't want to work on cloud, and if you want in-house something, then you can work on you use open source tools, like as I mentioned, HDFS. You can use Hadoop distributed file system, and you can
mhm,
simulate it right in your laptop. So you
mhm,
don't even need any cloud environment. You can download, have that HDFS setup in your, if you have a good machine, you can do
mhm,
that in your machine and simulate, and you can set up airflow. Then you can define all the related, because airflow also it's no cost. You have can develop a Docker image, and you can spin up in your local machine. So all those things, so the open source variant are there, and you can actually simulate the entire this architecture on your laptop itself.
mhm.
Yeah.
Okay, cool. I'll give back the floor to other questions. Thank you.
Yeah, Betty, thanks for your insight and comment, and I hope you enjoyed it and you got to know new things from the talk.
Yeah.
Absolutely. Thank you.
Oh, Jadam, I think I can answer one of your question. You'd ask how different, especially as the special data engineer relative to the general data engineer.
Yes, thank
Yeah,
you.
I just think the main difference, based on what I've been seeing, and I can even share a role here. It's basically that the geo we tend to focus on geo component basically because I think, for example, like Giant, maybe he hasn't done things like maybe reference system, right, or maybe processing tons of satellite imagery, and it might need some now the geospatial domain, and maybe this is what the roles geospatial data engineer keeps pumping up. Because actually most that pop up, I see they also tends to most likely involve some satellite data processing. So the one that I was saying earlier, let me see if I can share the screen.
Yeah,
So
so nowadays, yeah, the satellite data and things. For example, the Presto, right? Presto, Athena, we were talking about.
yeah,
Now they are maturing enough that now they have included a lot of geospatial related functions in their vocabulary. So now anything related to your points and coordinates, how the post GIS works, right? The functions
yeah,
you use with post GIS,
yeah,
all those have been made available in that Presto and Athena.
yeah, sure.
Uh, so you can do a lot, and also in Redshift. So there are a lot of
Yeah, there's some
amazing
other
things there.
Redshift
Yeah.
special. And even Google is also doing, the GCP is doing. I think the one lagging behind a little bit is Azure, but yeah. So for
Mm.
example, Amazon, you see all the special functions they're implementing now on Redshift,
Yeah.
and also Google BigQuery, definitely GCPs. Yeah, and all they're really trying to catch up and implement geospatial data engineering capabilities on these platforms, and that's really great.
Yes. Yes.
Yeah. So yeah, basically the difference is things like reference systems and just knowledge for geo stuff.
Yeah.
Yeah. Okay. Anybody else, or we call it the end? Is everyone satisfied? We can do the thumbs up. So that I'll be sure we are closing it at the right time then. Okay, perfect. Yeah, everyone is, yeah. Thank you all.
Great.
Yeah. Yeah, Jayant, it was really great for doing this.
Yeah.
Yeah, thanks. And at least it's more clear. So for
Yeah.
people who are really interested in geospatial data engineering, just do those. You realize you need to know Python and SQL, obviously. Then pick
Yes.
up any cloud infrastructure, maybe AWS or Google
Azure.
Cloud Platform or Azure, and just try to play around and understand it, and how to do data warehousing, the data lakes. Yeah,
Yeah.
that's a good start for to apply to these roles.
Yeah, and also, Brian, what I think is, I mean, if any one of like based on the feedback you can collect, so if there is any specific topic of data engineering wherein you want more insight, for example, how to write a data pipeline in Airflow, like using Python, or how SQL plays an important role within the data pipeline itself,
Mm.
how to do this data crunching and munging. We can have some session. Now, this time it was only we didn't have any slides or anything
Yeah.
or nothing hands-on. Maybe sometime we can have that kind of aspect based on if the interest of the audience. So that will be like hands-on session wherein you can do something live, and maybe it will make relate more that what we spoke about today.
Oh
That,
yeah,
yeah,
sure.
depends on the, yeah, interest of people. Yeah.
Yeah, sure. Yeah. So guys, we've had. So if there's a specific area in data engineering that you want us to get started with, yeah, we'll discuss this, and yeah,
Yeah.
we can have Giant over and yeah, to showcase us how to do that. Okay, bye. It was good having all of you.
Yeah.
I hope it's now clear what the role entails, and yeah, see you all next
Okay.
time.
Yeah, sure. Thanks, Brian. Thanks for
Yeah,
setting
thanks a
this up.
lot, man.
Yeah,
Thanks.
yeah,
Yeah.
yeah. Bye. Bye.
Bye.
Bye.